Hello, in this video, I'm going to talk about glomerular filtration in the nephrons in the kidneys. So, glomerular filtration is the first step of urine production. So, it's one of the important functions of the nephrons in the kidneys. So, fluid is pushed from the blood inside the glomerulus into the renal corpuscle by blood pressure. Okay, so the blood is entering into the glomerulus, the tangled capillary network. The blood is going into that capillary network, and there's blood pressure in that capillary network. So that blood pressure is the pressure that's causing fluid to move from inside the glomerulus through the wall outside the glomerulus, just like we see in capillary blood exchange. But in this case, the fluid that is leaving that capillary network is being collected by a surrounding capsule. So, the filtration in general is the forcing of fluids and dissolved substances smaller than a certain size through a membrane by pressure. So, blood pressure is the pressure that is forcing the fluid and the dissolved substances through the wall of the glomerulus. And then we're going through a couple layers of cells there that are filtering so that larger particles stay in the blood and only things that are small enough to make it through the filter are able to leave the blood and become glomerular filtrate. So the net filtration pressure means we have to consider the blood pressure that's pushing the fluid out and the resisting pressure. Okay, so blood pressure in the glomerular capillaries causes the filtration. So it causes the fluid and the dissolved substances to move through the wall of the glomerulus. That filtration is resisted by two pressures. One is the blood colloid osmotic pressure, just like in normal capillary exchange. So it's the osmotic pressure of fluid due to its solute concentration that pulls fluid into the capillaries. Okay, so because there's a higher concentration of all sorts of solutes in the blood than there is in the space outside of the glomerulus, that creates this osmotic pressure that wants to draw fluid back into the blood vessels to make the concentration gradient equal on either side. So that's the blood colloid osmotic pressure, also referred to as oncotic pressure. So that's a pressure that's trying to draw the fluid back into the glomerulus. So that's resisting filtration. The other opposing pressure is the glomerular capsule pressure. So, as fluid is leaving the glomerulus and is being collected inside of the capsule, the pressure of the fluid inside the capsule is increasing because it's an enclosed space that's filling with fluid. The more fluid it contains, the greater the pressure it exerts, resisting more fluid from coming from the glomerulus out again. So, as long as the whole nephron is working properly and the fluid continues to flow through the whole renal tubule, then that glomerular capsule pressure should remain about constant and should be low enough that blood pressure overcomes the blood colloid osmotic pressure and the glomerular capsule pressure so that filtration continues. If there was some kind of injury or problem and the fluid was not passing through the renal tubule, then that glomerular capsule pressure would increase as the fluid, as the filtrate increased. And if that pressure became great enough, it would overcome the blood pressure and there would be no more filtration. So that nephron would stop filtering. So net filtration pressure is the glomerular capillary blood pressure. So the pressure pushing the fluid out of the blood vessels. And then you subtract from that the two opposing pressures. So the blood colloid osmotic pressure and the glomerular capsule pressure. And so that's the net filtration pressure, is basically how much pressure, when we subtract out the resisting pressures, how much pressure is causing filtration. So the net filtration pressure stays relatively constant, and we do that by changing the diameter of the arterioles that are coming and going from the glomerulus. Because if we change the diameter, then we can adjust essentially the blood pressure. So we can adjust how much pressure is there in the glomerulus by either making the diameter smaller or larger of the blood vessels that are coming and going. So that's how we regulate net filtration pressure, is by regulating blood pressure in the glomerulus. Glomerular filtration rate is the amount of filtrate that forms in both kidneys per minute. So our rate of forming glomerular filtrate. So we want GFR to remain constant. It will fluctuate a little bit depending on different exposures and things. So we'll fluctuate a little bit, but we want it to remain relatively constant, because when GFR is high, that means that the fluid is moving through the whole tubule too quickly. And then we don't have as much time for reabsorption and secretion. So we won't be able to reabsorb as much of all of that water that's coming through and the needed substances that we want to reabsorb. And we don't have as much time to secrete things like ammonia that we want to get rid of. So if GFR is too high, that will cause greater quantities or larger volumes of urine to be formed, when really the body might want to retain that water, but instead we're losing it because there isn't enough time in the tubules for it to be reabsorbed. If the GFR is too low, so it's happening too slowly, then unfortunately we're reabsorbing too much of the filtrate. So things that we want to get rid of, they're sitting there so long that we end up reabsorbing them. So eh, we're not excreting the waste adequately that we're trying to get rid of. So we do want GFR to stay relatively constant, but there are some things that will affect GFR. Like, for example, caffeine will speed up GFR, which is what makes it a diuretic. So there are a lot of different diuretics. Those would be anything that causes us to increase our volume of urine. So anything that's causing us to lose water that ordinarily our body would want to retain. So there are different mechanisms that cause something to have a diuretic effect. So it could act on antidiuretic hormone. It could act directly on our GFR. In the case of caffeine, it's by affecting how much the arterioles are able to regulate our blood pressure. So it increases the blood pressure, which increases the GFR. That's in the case of caffeine. Other substances can affect how much how permeable the tubule is in different regions, and therefore how much we're reabsorbing or secreting certain substances throughout the tubule. So there are lots of different types of diuretics. So that's one example. So caffeine will increase GFR. High blood pressure chronically will increase GFR. Um, Diabetes mellitus could increase GFR. We're trying to flush out as much glucose as possible, and the person will lose a lot of water in that process. They're trying to get the glucose because the glucose is too high in the blood, so they need to excrete it. GFR could be slow. It could be sluggish if someone has very low blood pressure and they're not able to achieve a high enough blood pressure in the glomerulus to have a normal GFR. Or anything that's affecting kidney function could slow down GFR. So there are all sorts of conditions, medications, different exposures that could increase or decrease GFR, and that would affect how much water we're losing or retaining, and whether we're able to adequately excrete waste that we're trying to get rid of. Okay, so thank you so much for watching, and I'll see you for the next video.